In the name of God, Engineering, Mechanics, Statics, J. L. Merriam, L. G. Craig, 7th edition, Chapter 5, Distributed Forces. We have an introduction first. In the previous chapters, we treated all forces as concentrated along their line of action and their point of application. This treatment provides a reasonable model for those forces. Actually, concentrated forces do not exist in the exact sense, since every external force applied mechanically to a body is distributed over a finite contact area, however small. Let me take a note here. Concentrated forces do not exist in the exact sense. Since every external forces applied mechanically to a body is distributed over a finite contact area, however small. The force exerted by the pavement on an automobile tire, for instance, is applied to the tire over its entire area of contact as shown in this picture. Distributed forces example. When analyzes the forces acting on the car as a whole, if the dimension B shown in the picture here of the contact area is negligible compared with the other pertinent dimensions such as the distance between wheels, then we may replace the actually distributed contact force by the resultant R treated as a concentrated force. Even the force of contact between a hardened steel ball and its race in a loaded ball bearing, as shown in this picture, is applied over a finite, though extremely small contact area. Consider this picture. Another example of the distributed forces. Or another example can be the force applied to a two-force member of a truss. Consider this picture at joint point. This is another example of actually distributed forces in a mechanical systems are these forces are applied over an actual area of contact of the pin against the hull and internally across the cut section as shown. In this and other similar examples, we may treat the forces as concentrated when analyzing their external effects on body as a whole. If, on the other hand, we want to find the distribution of internal forces in the material of body near the contact location, where the internal stresses and strain may be appreciable, then we must not treat the load as concentrated but must consider the actual distribution. This problem will not be discussed here because it requires a knowledge of the properties of material belongs in more advanced treatment of the mechanics of material and the theories of elasticity and plasticity. When forces are applied over a region whose dimensions are not negligible compared with other pertinent dimensions, then we must account for the actual manner in which the force is distributed. When forces are applied over a region whose dimensions are not negligible compared with other pertinent dimensions, then we must account for the actual manner in which the force is distributed. We do this by summing the effect of the distributed force over the entire region using mathematical integration. This requires that we know the intensity of the force at any location. There are three categories of problems in distribution forces and the area or line of application consider will be discussed in the next chapter.